Okay, here's a way to remember the unit circle, you guys. First I'm going to draw the unit circle. And then I'm going to plot the points because each one from the center is 1 point over. Alright, the circumference of a circle is always going to be 2 pi times the radius. And then the radius is always going to be 1 because you're only going 1 over. So it's going to just be 2 pi. The distance around a circle is always going to be 2 pi. And when you always do a circle, it's always going to be 360 degrees. So you could also remember as 360 is also 2 pi. So if we go the entire way, we'll go from 0 degrees to, which is like equivalent to 2 pi. And then to get the radian for over here, you take half of 2 pi, which is always just going to be pi. So you do it there because if you're going half around the circle, then it's always going to be half. So that's for the point -1, 0. Alright, so now we're going to take this and cut it in half, because we want to get this radian, and this one's in between these two, so this one has to be pi over 4 because it's in between both of them. And then you do the same thing here, and this one's going to be 3 pi over 4 because we're just repeating the halving process. This one's going to be 5 pi over 4. And then the next one, we're going to get 7 pi over 4. And then after that, you'll be back again at 8 pi over 4 or 2 pi.
Back at 8 pi over 4, which is 2 pi. Now we can do the same thing with the smaller angles. This is pi over 6. That's equivalent to 30 degrees. You take 180 and divide it by 6. Okay, now we do the same thing. This is 60 degrees, and that corresponds with pi divided by 3. All the way around, that's 6 pi over 6, but we go a little bit less, so this is 5 pi over 6. Same thing, this is 7 pi over 6, because we go a little further. And if you go all the way around, you'll be at 12 pi over 6. Or 2 pi, but we go 1 less. So that'll put us at 11 pi over 6. We have pi over 3 here, so 2 pi over 3 is going to be up here in this corner. 3 pi over 3 will put you over at the x-axis. So now we have to come down here and go 4 pi over 3. And then 5 pi over 3 over here.
Alright, so what you should have learned with what we just taught you is that in radians, 2 pi is always equal to 360. Also, what you should have noticed is that the denominators of these radians are always the same with their reflection. And the only way the numerators are different is because they're in different quadrants. So like quadrant 1's is different than quadrant 4's because like this one's pi over 6 and this one's 11 pi over 6, but the denominator stayed the same, just the numerator was different because of the different quadrant. For the points for these three is that first we're going to make fractions over 2. Alright, write 1, 2, 3 down, and then write 1, 2, 3 up. And then you take square roots of all the tops. So the square root of 1 is always 1, but square root of 3, square root of 2, square root of 2, square root of 3. And then these are just tips of ways to remember it. So what we're going to do next to find these ones over here is they're all the same at the corresponding angles. So like here, this is the same numbers, but the values are going to be different. Like the first one's always going to be negative in this side, because when we are looking over on this side of the unit circle, this first one, this quadrant 1, this is positive 1, comma 0. But then when we look at the reflection over here, this is negative 1, comma 0. And that's basically the same thing for all these values over here. So we're going to take the same one as this one at 60, which is 1/2, comma, radical 3 over 2. And we're going to take that, but instead on this side, since it's negative in the first number, we are going to make it negative 1/2, comma, radical 3 over 2. And you'll see that just the first one's negative, and so I'm going to go fill out the rest of this quadrant. Alright, and so now for quadrant 3, we're going to use the same technique we just used, but since we look in quadrant 3, these coordinates are negative 1, comma 0, and this one's 0, comma, negative 1. And these numbers are both negative, the x coordinate and the y coordinate. So both of our coordinates for this quarter is going to be both negative. So we're going to do the middle one just because it's easy, and so it's going to be negative radical 2 over 2, comma, negative radical 2 over 2. And we're going to fill out these other ones the same way.
So now we're in the positive x-axis but the negative y-axis. So the second number is going to be negative only. So here we're going to have root 2 over 2, comma, negative root 2 over 2. Then we're going to come over here and we're going to have 1/2, comma, negative root 3 over 2. And now we're going to have just the numbers switch, and it's going to be root 3 over 2, comma, negative 1/2.
In order to understand the next part, I need to explain to you guys that this x coordinate is always going to be cosine, and then the y coordinate is always going to be sine, and then in order to find tangent is always going to be y over x.
So we drew a line right here, which is the 30-degree mark. So that angle right here equals 30 degrees. Then we drew the line down from the point of intersection, and that formed a 90-degree angle. And since sine of 30 is equal to 1/2, the hypotenuse is going to be 2.
Basically, what we do next to find this side right here, we would do 1 squared plus b squared equals 2 squared. And then once we solve that, we're going to get b equals radical 3. So that's our side length for this one. So now we have our triangle, and if we wanted to, we could find cosine and tangent. So let's do that. So cosine of 30 degrees, cosine is always, let's write down SOHCAHTOA. SOHCAHTOA. So cosine is always adjacent and hypotenuse. So cosine will look adjacent, radical 3, hypotenuse 2. So cosine of 30 equals radical 3 over 2. And for tan, it would be 1 over radical 3. We have 30 degrees and 90 degrees here, so it's always going to be 60 degrees because we have the special triangle of 30, 60, 90. And basically this is just showing us how we can use a unit circle and geometry, which is like triangles and shapes, to incorporate that into trigonometry. So a lot of times we will be using geometry to draw triangles and then figure out the sine, cosine, and tangent of it. So it's basically going from geometry with the 30, 60, 90 triangle that we learn and taking it the next step further and using it for trigonometry. Unit circle